Bismillahirrahmanirrahim. Dear students, grade 11, and this is lecture number 70. And the last topic we are doing for the chapter number 12, grade 11 chemistry activity series of metals. The last topic of this syllabus means book. So activity series of metals, already I told you in the previous examples that one metal can displace other. The one metal or an element displaces other. That's like we done in the galvanic cell. Zinc displaces copper. Zinc displaces copper from its solution of copper sulfate. Fluorine can displaces all the halogens from their salts. Chlorine displaces bromine and iodine. Bromine displaces iodine, and iodine is not going to displace any halogen from its salts, aqueous solution of salts. So this is according to activity series of metals and non-metals. So suppose we have X. This is the X metal, and this is the Ay compound in aqueous solution. So is this X displaces A or not? Like this. Is this X metal can displaces A from its aqueous solution or not? This is the activity series, and already I gave you example for the zinc and copper. So dear students, the ranking of the activity series of metals, there is a top lithium, sodium, potassium. These are the alkali metals and highly reactive, and they can displace the hydrogen with an explosive nature. The reaction is very fast, explosive, and this activity decreases as we go down. In this ranking, metal and hydrogen are arranged in order to decreasing ease of oxidation onto their respective ions in aqueous solution. This arrangement is called activity series, page number 277, revised new book, edition 2020. In this ranking, metals and hydrogen are arranged in order to decreasing ease of oxidation to their respective ions in aqueous solution. This arrangement is called activity series. This activity series, if you see given here, table number 12.2. 12.2, on the top you are finding lithium, potassium, barium, strontium, calcium, sodium. This is the one group of elements. This group of elements categorize very reactive metals. These metals are very reactive. Lithium, potassium, barium, strontium, calcium, sodium. They react with the cold water explosively and liberate hydrogen gas from the water. Potassium and sodium, I told you, violently react. Avoid to put sodium in the water. Potassium even react with the ice minus 40 degrees centigrade, even minus. So the reaction is highly violent. Potassium and sodium react violently with water. They also react violently with acids. Acids are highly dangerous. With acid, this is a highly dangerous, extraordinary violent reaction. So don't put even small piece of sodium or potassium metals in acid. Highly dangerous. So these are the top. these group of elements on the top position, and they are very reactive, and they can react with the cold water to displace the hydrogen from the water, and highly violent reaction with acids. Second group, magnesium, aluminium, manganese, zinc, chromium, iron, cadmium. Starting from magnesium, aluminium, manganese, zinc, chromium, iron, cadmium series, this group of elements, they are metals of intermediate activity. Intermediate. They react with the steam, means when you pass steam on these metals, high temperature, they can react with the water to form hydrogen gas. Means hydrogen gas will be formed, hydrogen is displaced from water by the metal in condition boiling heat, means heat, steam, and with acids to elaborate the hydrogen gas. And mostly we prepare hydrogen gas in the laboratory by using aluminium, by using zinc, by using iron, because these metals are easily available in the laboratory. So for the preparation of hydrogen, to show the students their properties, so we use the aluminium, zinc and iron for the preparation of the hydrogen gas through acids. Mostly we use sulfuric acid. So they react with steam and react with dilute acids to displace the hydrogen gas from the acid. So these are the intermediate active elements. Again I am repeating: magnesium, aluminium, manganese, zinc, chromium, iron and cadmium. These are the intermediate active elements. Third group, moderately noble metals. Noble means they are not going to show the reactivity. They don't react. They are moderate, intermediate. Moderate noble metals: copper, silver, mercury. Moderate active metals. After the metals of the intermediate activity, there is the third group, moderate active metals: cobalt, nickel, tin, lead and hydrogen. Cobalt, nickel, tin, lead and hydrogen. Moderately active metals, they slowly react with the acid and they do not react with water. Cobalt, nickel, tin, lead do not react with water, but slow reaction with acids, hydrochloric acid. Then fourth group, moderately noble metals: copper, silver and mercury. They do not displace hydrogen, they are less reactive. So we are not going to prepare hydrogen from these elements. They are moderately noble. They don't react with the water. In acid, HCl, oxidizing acid and nitric acid, they can react. Hydrochloric acid react with the oxidizing such as nitric acid. So they can react with nitric acid. Copper, silver, mercury, they can react with a highly powerful oxidizing agent just like nitric acid. They don't react with water and hydrochloric acid, but these elements, copper, silver, mercury, can react with the oxidizing agent just like nitric acid. The very noble metals, platinum and gold. Platinum and gold, these are the very noble metals and they don't react with any acid. No chemical reaction with acids, but they can react with the aqua regia. Aqua regia is a mixture of 3 parts of the concentrated hydrochloric acid and 1 part concentrated nitric acid mixture. Put the gold, platinum, they dissolve, they react. So individually acid not affect on the gold and platinum, but aqua regia can affect these 2 metals only. So reaction with the aqua regia is a mixture of the 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid, aqua regia. So dear students, the questions are given here. According to this activity series, barium, this I already written here, this is the barium plus lead oxide to form barium oxide and lead. Can barium displace lead or not from its oxide? If you see the activity series of metals, barium in top position, first group, very active metal, and lead is a moderately active metal. So yes, this reaction can happen because according to the activity series, barium is the first group which is very active metal, lithium, potassium, barium. So this reaction, this displacement can take place. Yes, this is the correct answer. Sodium. Can sodium displace hydrogen from water or not? Can sodium displace hydrogen gas from the water or not? Yes, highly reactive, or we can say violent reaction. Sodium is the top. You can see very active metals. These metals react with the cold water to liberate hydrogen gas. So this reaction can happen according to the active metal series. So yes, this answer yes. Number 3, magnesium. Magnesium with cold water slowly reaction is quite slow, but the hydrogen bubbles are going to be formed on the top of the water. There is a formation, chemical reaction is slow but form because magnesium is a second group, means metals of intermediate activity, means more reactive than the hydrogen, so they can displace the hydrogen from water. The reaction is slower one, not fast. Magnesium acid, yes, it can react with acid because it gives the hydrogen gas, and magnesium chloride, the chemical reaction is means you can liberate hydrogen. This is the most metals intermediate activity, magnesium is there. So you are going to see this activity series of the common metals. The metals, they are higher on the list, top, they can displace. Metals higher on the list transfer electron to metal cation, lower on the list, greater the separation between the species of more vigorous the chemical reaction, just like powder zinc lead oxide is going to be lead is going to be reduced, and magnesium barium is going to be oxidized. Iron also, sodium very active metal, magnesium is active metal, reaction is there. The moderately active metals, cobalt, nickel, tin, lead and hydrogen, with a hot water, react with hot water, react with a stream of hot water and acids to liberate hydrogen gas, cobalt, nickel, tin, lead and hydrogen given here. Then I told you the moderately active metals, then moderately noble metals. Metal below hydrogen, copper, silver, mercury, they are below hydrogen. Moderately noble metals in the activity series do not react with 1 molar solution of hydrochloric acid. These metals are unable to reduce the hydrogen to hydrogen gas, so they don't react with the acid. No chemical reaction, but they can react with nitric acid. These metals called noble metals, and they don't react with the acids. Only the oxidizing agent nitric acid they can react. And very noble metals, already I told you, platinum and gold, they only react with the aqua regia but no with the acid. They are the one thing that magnesium metal reduces silver or not. Can magnesium metal reduces silver or not and oxidizes or not? Yes. Magnesium top. Very active metal magnesium. Next means metals of intermediate activity. Magnesium is number 1 in this group. Magnesium is top. And silver is down, moderately noble metal. So magnesium is more reactive than metal. So this chemical reaction happen, and yes, the answer is yes. Calcium and water, yes, calcium also present in the very active metal, group number 1 elements. So calcium can displace the hydrogen gas from the water. The chemical reaction is feasible, yes. Self-assessment 12.9 predict whether reactions occur in the following cases. Write the net ionic equation for the reaction. Iron Nel is placed in 1 molar solution of HCl. Iron Nel. Dilute solution of HCl. So I am writing chemical reaction, then give the answer yes or not. So is this chemical reaction happen or not? Means can iron reduce hydrogen or not? So if you see the activity series of common metals, iron is present in the second group, metals of intermediate activity. So hydrogen present in the third group, moderately active metals, and hydrogen the last element for this. So this can happen. So this chemical reaction is yes. This can displace. Now number 2, lead oxide is heated with the zinc powder. Lead oxide is heated with zinc powder. This is a zinc. So is this chemical reaction is feasible or not? Can zinc displace lead from the lead oxide or not? Or can zinc reduce lead or not? So if you see the activity series of common metals, so zinc is present in the second group, metals of intermediate activity. Metals of intermediate activity, and lead is present in the third, moderately active metals. So yes, this happens, this can. Zinc can displace lead ion to form a lead reduction taking place and oxygen taking place in the zinc. So this is happening according to the activity series of the common metals. This is correct. Nickel wires placed in a solution of silver nitrate. This is a nickel wire, and we have silver nitrate aqueous solution. So can this reaction happen or not? Is nickel oxidizes or not, or silver reduces or not? Yes or no? So according to the activity series of common metals, if you see, nickel is in the third group, moderately active metals. Second element of this cobalt, then nickel. And silver is a moderately noble metal, so nickel is more active or reactive than silver, so this reaction is yes, can happen. Reaction will occur. The answer is that reaction will occur according to activity series of common metals. So dear students, we complete here. This is the last topic we done. So here in the exercises you have like these questions here. I am going to here, if you see the exercise question 2, explain why, 290 page exercise question number 2, explain why. Reduction of 1 mole of zinc positive 2 and silver positive 1. This is Faraday's law. This is not present in your syllabus. Write the spontaneous reaction for the following set of the half cell reaction. Already I told you, gold reduces 1.5 volt and nitrate changes into nitric oxide 0.096, and I told you that the reduction of cell which has more positive value will be reduced, and the reduction cell which has more negative value is going to be oxidized. So dear students, gold will be reduced and nitrate is going to be oxidized. Explain following reasons. Oxidation potential of zinc is plus 0.76 volts and reduction potential is 0.76 volts. According to the electrochemical series, on the top of the list, they have the negative reduction potential because these are active metals. They are reactive metals. They are above the hydrogen. So above the hydrogen in the activity series, they have a negative value. So reduction potential is negative for the zinc in activity series. If you inverse it, it must be positive. So oxidation potential is positive and reduction potential is negative. Salt bridge, I told you, which has ability to connect the solutions together without mixing two solutions, and it maintains the neutrality of the two solutions. Only it passes the ions, migrate ions in presence of the ionic solution present in the salt bridge. Sodium and potassium can displace hydrogen because according to active series, sodium and potassium the top, very highly explosive chemical reaction with the water. But the copper and platinum do not, because they are, platinum is a noble metal and the copper is a moderate noble metal, so they can't. So also there are questions, other questions also. Use the activity series matrix to predict the product following displacement reaction. So dear students, here I am going to solve this. You should have the idea about the activity series, active series with values and without values. With values you have to calculate the electrode potential, cell potential you have to calculate, and without values just you have to explain the chemical reaction is feasible or not according to the activity series. Copper, this is question number 15. Copper, solid and HCl. So if you see the activity series, there is the activity series here. There is the activity series and copper. If you see copper, moderately noble metal, second last, first element of moderately noble metal, second last group. Hydrogen is moderately active metals along with metals hydrogen. So hydrogen is above and the copper is below. Hydrogen is above and the copper is below. So that is why this chemical reaction will not happen. Copper does not. Do not react with water and HCl. Written. No chemical reaction. No hydrogen gas is formed. No oxidation of copper according to activity series of common metals, page number 278. No reaction. Written. Do not react with water and HCl but react with the oxidizing agent just like nitric acid. So no reaction taking place. Magnesium and chromium chloride. Magnesium and chromium chloride. So this reaction happened because magnesium is a second group metals of intermediate activity, and chromium is down. Magnesium, aluminium, manganese, zinc, chromium down. So this happened. Yes, magnesium is more active than chromium. That's why you will get magnesium chloride and chromium. So this chromium is going to be reduced and magnesium is going to be oxidized. So this chemical reaction, yes, according to activity series of common metals, this chemical reaction feasible, happen, yes. Nickel oxide and hydrogen. Nickel oxide and hydrogen. Is this chemical reaction happen or not? So you can see according to activity series of common metals, yes, this is the group number 3, moderately active metals react slowly with the HCl and do not react with water. Do not react with water. So but they can react with the hydrogen because of the nickel is going to hydrogen. Can hydrogen, yes. Can hydrogen displace nickel? No. Hydrogen is down. Hydrogen is down. I am reading here. This is in the moderately active metals: cobalt, nickel, tin, lead, hydrogen. Hydrogen is the last element of this group. React slowly with HCl, do not react with water. So halogen has no ability to displace liquid from the oxide, so this reaction is not feasible. Cadmium and copper sulfate. Is this chemical reaction feasible or not? Cadmium. Yes, because cadmium is the last element of group 2, metals of intermediate activity. Second group, metals of intermediate activity, the last element, magnesium, aluminum, manganese, zinc, chromium, iron, cadmium lost, and copper is a moderately noble metal. So yes, this can. You will get cadmium sulfate, so cadmium will be oxidized. This is copper is going to be reduced. Copper is going to reduce, so this chemical reaction is feasible, yes, according to activity series of common metals, table number 12.2, page number 278. So dear students, these are the questions I told you, and you have to solve them. All these I solved here, and you have to calculate and also solve the exercises questions also. Now your syllabus is going to be complete here, so you have to watch all lectures available on YouTube for all teachers. They are saved. So if you have a difficulty, you contact the school. Inshallah, I will help you. Because of the conditions we don't know throughout the world. In Pakistan, you can watch the television, you can see from the other sources that corona is going to be spread, and we don't know what the situation, but maybe the Ministry of Education, they are going to be continue the education, but I don't know, after 1 week there is a decision. So please, you have to prepare in all kinds of directions, according to the environment, according to the atmosphere provided by the Ministry of Education Pakistan. We don't know what is done. So please, you have to prepare, watch the lectures very well, solve exercises questions, solve also board papers according to the reduced syllabus. So if you have a difficulty, contact the school. So inshallah, we will help you. Thank you very much. God bless you, and pray for me also. Thank you very much, please.